Hello and good day to all of you. Today I am going to discuss about very important machine learning concept, regression. So regression is defined as a supervised learning machine learning mechanism. So if you take machine learning as a whole, there are multiple flavors of machine learning as supervised learning, unsupervised learning, reinforcement learning, likewise. So I am planning to do a separate video session elaborating on those aspects. But today's session is going to be fully dedicated on the concept of regression. Now, regression, as I mentioned already, it's been defined as a supervised learning mechanism, supervised learning approach. So basically, if you consider about regression, there are multiple types of regression, as simple regression for single variables and for multiple variables. Then we have logistic regression and binary logistic as well as multi-class logistic. So these are few types of regressions. So in today's session, I'm going to mainly focus on the concept of single variable regression, and we are going to create a regression model using Python to facilitate some practical value prediction, right? Okay, let's move forward. So regression can be identified as a sort of a relationship between two variables, right? So regression is the name of this relationship. So in a regression relationship, basically we can identify an independent variable as well as a dependent variable. If we are to plot a particular data distribution in a graph, usually the independent variable will be plotted in the x-axis and the dependent variable is going to be plotted in the y-axis. So the meaning of these two variables are, when the independent variable is altered, accordingly the dependent variable will be getting adjusted, right? So you can see a very simple data distribution here. I have two variables, area and price. So area, it could be the size of a house, right? Or an apartment size. So simply you can see when you are going down, when the area size is increasing, proportionate to that, price also has got increased, right? So we can identify simply this as a linear relationship because proportionately price is increasing when the area is going to be increased. So if we plot this relationship in a 2D space, you can see the in the red color, as red color cross marks, we have identified the respective data points, and the most optimal regression line has been drawn. Now you can draw multiple lines because you can notice here that all the data points are not intercepting with this line, blue color line drawn, but this is the best line that you can draw. How can you decide on that? You can draw multiple lines, right? And you can calculate the deviation associated with those lines from the respective data points. And finally, you can identify the data line, sorry, you can identify the regression line which is leastly deviated, and that can be identified as the most optimal regression line. So here I have not drawn multiple data lines. So the most optimal data line has been depicted here. So what is the value of this regression relationship? If you know the value of the independent variable, as I am pointing in my cursor, you will be able to uh, derive the dependent variable value. Now here you know the area value, so you slightly move across until you find the intersection with the regression line, and the corresponding value associated in the y-axis will provide you the respective dependent result. So in relation to the use case that we are discussing, why or the dependent variable is defined as the price, and m is the slope or the gradient, which is a sort of a ratio. Then x value is being defined as the independent variable. According to this use case, x is going to be the area and b is the intercepting point, right? So where the y-axis being crossed, that point is being identified as the intercept. This is a very basic concept that you might have studied basically in your school days. So as I already elaborated, according to the use case that we are going to discuss today, price is defined as the dependent variable and area is defined as the independent variable. Okay, so let's create this supervised machine learning model. So for this purpose, actually I'm going to use Google Collaboratory, because the advantage or the value of Google Colabs is it's a readily available environment for you to write your machine learning code in Python, right? And directly it can be saved in your Google Drive. So your source codes will be available in the Google Cloud whenever if you have internet connectivity, despite the location, you can access those, right? So you don't need to do any physical configurations, downloading and installations, nothing. Directly hand over all those burdens to Google Collaboratory and it will sort those for you. So I'm going to search for Google Collaboratory. So you can see Google Collabs, right? Okay, so Google Collab. So you can carefully follow the steps that I'm following from now onwards. Let's go to Google Collabs, right? So you can create a new notebook, right? So here I'm going to utilize a file which I have already created. So click on that. So it will be laying off the coding environment for us, right? So the file is labeled as simple regression. That is the name that I have given. Henceforth, you have to click on here and make sure that you are connected with the real-time Python environment for the purpose of doing your coding, right? So I erased what was there. So let's start from the scratch. So here the thing which is visible in the ash color, we refer that as a code block, right? So you have the facility of executing the code that you are writing inside this code block. Okay, so I'm going to import pandas as PD, right? Pandas is very important in creating data frames. So data frame is actually it's like a sort of a photocopy or a snapshot of the data set that you have. You can take a photocopy of the data set that you have, which is a data frame, and you can apply various manipulations on that photocopy that you have taken, which is a data frame. Therefore, pandas plays a vital role in most of the machine learning problem solving. So let me comment the purpose of this. In order to create a data frame, right, which is something like a photocopy of your actual data set, right, where you can conduct various manipulations. Okay, panda is ready. Next, I'm going to import another package which is numpy, right? Now numpy is basically used for mathematical calculation purposes, mainly. But in here, actually, significant amount of Panda's internal coding is interdependent on NumPy. It uses functions which are residing inside NumPy. Therefore, I'm importing NumPy here as well. That is for the calculations, and Panda is using some of the features of NumPy, right? So therefore, we can say it's interdependent, right? Interdependent, right? So I'm putting comments for you can understand the purpose why we are doing this. Then I'm going to import matplotlib as PLT. This is for the uh, plotting purposes of data distributions, right? So you can graphically analyze, right? Graphical plotting purposes of data distributions. Okay, then next I'm going to import sklearn library, right? Sklearn is a very crucial library which is being used in machine learning because it contains a lot of machine learning algorithms residing in that. So we don't want to use everything. I want to only use the linear model because we are going to do a linear regression. We are about to do linear regression, right? Okay, now I'm going to apply this this linear model to a specific data file. So I have to read the file externally. So therefore, I am configuring some input output pipelines, Google Colab, right? From that, I need to import files. Then let's create a variable called uploaded, right? Uploaded equals to file, right? Uploaded is the variable name, files dot upload. Okay, so I think if you recall previously, uh, I showed you the area versus price data distribution, data set. So I have saved that file in my machine as a CSV file, right? CSV file. So now I am going to read that file and import the contents of that files to this uploaded variable, right? So let's execute. Okay, there appears a widget for me to upload the file. Choose files. So this is the so-called file that I mentioned. So inside this file, I have the respective values in the sense the area and the price, right? So I have saved it as a CSV file. So let's upload that. Uploading is completed, right? Okay, next we'll add another code block. Shall we read this? So input output operation occurs, input IO, right? So let's create a data frame variable df, right? So I'm going with the help of pandas, I'm going to create a copy, right? Read CSV. Okay, so io dot string IO input output operation. Then it's available in the uploaded library, uploaded, right? Sorry, uploaded variable. Here it's been saved as an array, so that is the file that we read, and let's decode it to UTF format for the readability purposes, and I hope we are okay. Then let's print the values inside the DF and we'll see what is the output. Yes, you can see, if you can go back to my recorded video, you can see these were the prices that I was elaborating in, and the area values which I was elaborating in my PPT. So how these values came here? We imported the file values.csv, and those values were read by this read CSV command with the help of the pandas object PD, and it is stored in another variable, data frame variable, and I just printed that. Okay, so all good up to now. So next thing that I'm planning to do is I'm planning to add another code snippet. Okay, so let's see the distribution. So I'm going to use the pyplot plt dot x-axis. I want the x-axis which is containing the independent variable. It's going to be the area. Then plt, let's have the y-axis, y label, yes, that's going to be the price. Okay, so I'm going to show this distribution in a scatter plot, right? So what are the things we want to display from the data frame, right? We created earlier. I need to read the area, which is the independent variable, comma, then I need to access the price, right? So let's execute this. Okay, so you can see the distribution. So it's mostly, as you can see, a linear type of a distribution, right? So you can see price is the y-axis, x-axis which contain the independent values, and the dependents and the respective data points have been plotted here. Okay, so let's get ready to create our regression model. So I'm creating a variable called reg because of the regression. You can give any name, right? Linear model, we already imported that, right? On the linear model, we have multiple regression types, which I showed you in the presentation earlier. Now we are going to do simple linear regression, right? Not the logistic regression. We are going to do a linear regression. Okay, so now we have a linear regression object created ready. Then let's use the fit command. Fit command is used for the training purpose, right? Keep that in mind. Fit command is used for the training purpose, right? So I am going to use the data frame, right? So you have to submit the values in form of a two-dimensional array here, right? That is the method signature, how it is going to accept the independent variable, which is area. Then the dependent variable is the price. Okay, so fit command is used for the training of the model. Now in here we created created the skeleton model, right? Only the skeleton. We don't have flesh, only the skeleton. We don't have trained the model. And here in the this is the line which we are actually going to train the model. Okay, let's execute this. Seems to be an error. Here it's rec, not ref. Rec.fit. Let's execute. Yes, model is ready now. Okay, now we are able to do the predictions. Shall we do a prediction? So reg dot predict, right? So we have to provide the independent variable value in form of a two-dimensional array, right? So let's say the area. So let's say hence the area has to be supplied as a two-dimensional array. So we have provided the additional brackets because that is the method signature. So let's say if the area is 2000 square meters, what will be the respective price? Yes, this is the predicted value. This is the respective price, right? Now how this value is calculated? I'm adding another code block. So let's get the gradient of this. Where here it's been defined as the coefficient. So the this is the m value, right? And let's have the intercept value as well. Rec dot intercept. This is the mx plus c value or the b value, right? Okay, shall we now analyze how the final result is derived? So we are aware that equation is y is equal to mx plus c, right? So y is the dependent variable, that is the value that we need to calculate. Let me put that as y. And m value is this coefficient value. So let me put that value here. This is the m value. Okay, and multiplied by x value is 2000, that is the independent variable value. We want to calculate the dependent value. Okay, let's add a bracket here, and plus, plus the interception value, right? And then we'll print y. So this is the result that we got. Okay, coefficient value is, sorry, wrong calculations, I guess. Coefficient value is this value, right? So let's paste that. This is the m value. Okay, m value is there, and the x value is 2000, and the c value is this value. I think it's correct. Yes, so you can see the output I got and the prediction output is almost the similar. So that is the way how a regression model is performing its calculation. Okay, thank you very much for staying with me, and we did a complete hands-on session associated with the simple regression concept. Stay tuned. In my upcoming videos, I am planning to discuss some more complex examples associated with regression concept. Thank you very much.